Hey everyone, welcome back. So in this video, I'm planning on trying to get as far as we can towards finishing it. If it becomes too long of a video, I'm going to break it up into probably 2 or 3, depending on how long it takes to explain all the logic going into this takes. So with that, I also wanted to mention that I've been getting a few messages here or there about um, how this project kind of gears towards working on Android, and apparently people have been having issues and with like the screen size and everything for the loading screen, and that is because of a little thing I overlooked. Because I'm kind of gearing this project more towards desktop. I haven't really been focusing on how it would look on Android, and that's only because I want to get you guys used to the framework prior to actually utilizing it and dealing with scaling issues on Android devices, because that's where things really, you got to take into account like aspect ratios and whatnot a little bit more aggressively. And I didn't want to burden you guys with that kind of same thing just yet. There are videos I'm planning on doing um, for getting this project, like a few extra outtakes for getting things working on Android perfectly and looking nice and whatnot. But from what I've heard, the project does load up right everywhere else. It's just the loading screen that seems to have a few size issues by loading the bottom left. And this is because when dealing with a shape renderer, um, or any kind of batch renderer, you need to set the context of which it will be drawing in, that being the viewport that it's going to be working with. And as you notice, we make the loading bar relative to the camera's viewport height and width. And when you don't set the projection matrix for the shape renderer or any batch renderer, um, it'll work with the default one. And so that's not what we want to do. There's a simple fix for this, and people have already informed me that it does work right away. So hopefully it'll clear up some sizing issues for your loading screen as well. So what you want to do is just have shape renderer dot set projection matrix to the apps camera dot combined view, and that'll give it the context that it's going to be working with for the right camera resolution and everything. So once you set that, everything should be working accordingly and everything should look normal on Android. Otherwise, for the other screens, because we are using a stretch viewport, people have told me that things look fine here, and all the other screens. It was just the loading screen that was a little bit off, which is glad that we took care of that ahead of time. I actually wasn't focusing on Android at the moment, so hopefully for those of you trying to get your project thrown onto Android right now, that should clear up that little issue. So just remember, any kind of batch or sprite batch renderer or shape renderer or anything, always make sure you're setting the projection matrix that it's going to be working with. So anyway, now with that out of the way, let's start finishing up some of the game logic and actually getting in some interactivity with our sliding buttons. As you remember last time, we set up this init grid, and this establishes all 16 buttons of the grid. However, we do have a hole that we want to implement, and I realized the logic I was trying to get in place last time was actually right. I just should have tested it when I had it in, and I didn't. So let's just get that back in real quick to actually establish the hole. So I does not equal hole y, or j does not equal hole x. And then we can throw all of this into that if statement, and now if we try loading it, it'll make sure not to put a button, and it'll just be null in wherever the hole was supposed to be. So there we go. Now we have a missing button. Perfect. So next thing we want to do is create the click listener for each of these buttons. So now we can start playing our game once we get this in. Granted, there won't be any indication yet of whether or not we won or selected an invalid move, but we will have some sort of text label that will be able to inform the user whether or not they incurred an invalid move or have won the game. So that'll just come a little bit later once we actually get the game working. So first thing we want to do is get the click listener set up. So that's going to be so move button click listener. We're just going to take this listener up here because, as usual, like I say, I'm kind of lazy on typing those types of listener inputs. J dot. I guess I got the whole thing. So yeah, there we go. Now that you have that, we're going to be setting an event that anytime we click on a button, it will slide the button. So slide or move button, and we'll just shorten that comment there a little bit. By the way, do comment your code a little bit more aggressively than I have been. For the sake of tutorial, I don't want to bog you guys down with like trying to figure out what to type for comments at the moment. I just want to get you guys into working code so you can see things faster on screen. So be a little bit more aggressive than just like 1 or 2 comments here. If you have a whole bunch of logic going on, that might be a little bit confusing. So you can know down the road, or again, if you're working with someone else, just add comments for certain little fixes or things that you added, just so you don't forget if you haven't touched your project in a long time. So back to the click listener. Because we won't be able to know just from getting the clicked button, we won't know where that button is exactly in the grid. We need to do a quick comparison and search through our grid to find out what X and Y our button is at the moment in the grid, or rather our I and J index, like row and column location. So to do that, first we want a few variables to work with. We want int button X equals 0, and int, or I'm sorry, that can just be button Y equals 0 also. And then, yeah, so I'll just leave that like that. And Boolean button found equals false. And then we're also going to have a reference to the button that was clicked, so that way we can actually have a point of reference to be checking through our loop. And with this input event, you actually get a lot of information about what just happened, like if a actor was clicked or a key was pressed or something that influenced a certain actor. You get all that information in that input event, which is really nice. And so you have this slide button reference, and that's just going to be the selected button equals slide button, and you do have to cast it. And to get the listener event button that was, or the actor that was relative to the event, you just do event.get listener actor. And there we go. So once we have that, we can start looping through our button grid and figuring out which row and column the button is currently located at. So to do that, we just have for int I equals 0, I is less than board size, I plus plus, regular 2D array looping maneuvers, so less than board size, j plus plus, okay. And then we want to make sure that while looping through, we don't hit the hole and get a null reference, a null error. So we want button grid I j does not equal null. And then, actually after that we can just have selected button equals button grid I j. So in this statement we're saying if we haven't hit the hole and the button we're looking at right now is equal to button grid of the I and j we're currently at, then we can set button x equal to j and button y equal to I, and that is because, again, I is the current row we're on, which is the y value, and j is the current column we're in, which is the x horizontal value. And then we can set button found equal to true and add some more arguments into our for loop up here, and button found. That should be not button found, and not button found. Okay, so with this, this will allow us to just kind of keep our for loop short and sweet. So like once we hit that button, we don't have to do any extra work because we set this button found equal to true. That way we can just jump out of this loop and just move on because we found our button that's relative that we want to work with. So with that, now that we have our button, we want to make sure the button that was clicked is actually on a row or column that can be moved or slid along, which means we need to be in the row or column that contains the hole. So if hole X is equal to button X or hole Y is equal to button Y, so one or the other. If the hole X is equal to button X, that means we're going to be doing a vertical slide. If the hole Y is equal to button Y, we're going to be doing a horizontal slide. And that'll make sense in just a second once we start actually getting the action to move our buttons in place. So we're just going to put out a system.print line real quick to make sure the logic is all in check. And button found, clicked, just kind of get a bit of information in there, plus, yeah, so that should be selected button dot get ID plus button X, put a space in between it, and button Y. Okay, so our game now should only print out if we found a button that is along the same row or column of the whole, and because like I said, if we're not on the same row or column as this whole, we shouldn't be able to move. So if I click this one, yep, okay, so far so good, so far so good. We're not in the same row, we're not in the same column as the whole, but now 13 is in the same row, so it should print out. So yep, it is at index 0 and 3 for the Y. So that is the exact number that we want. 14, 1, 3, 15, 2, 3, etc., etc. These are all looking great. So I think we're ready to move on to actually getting our buttons to move. We can just comment that out, and you know what, you can even just get rid of it because we're going to be calling a method here in just a second. We're going to call this move buttons, and we're going to pass it the button X and button Y. All right, and we can come down here, call or create our move buttons method, and int button X, int button Y. Okay, and in this method, we're going to be doing something that will allow our game to be universal in the way we move our buttons. It'll make it easier on us in the long run, so we don't have to handle a whole bunch of random cases. That'll make things difficult. So let's say you just want to move the 15 over 1, so you can start moving tiles on this row. Well, we can do that, and that's all fine, but what if you select 14 and want to move 2 tiles at once? This is more of an approach for people who want to play the game a little bit faster and move more tiles at once. So the case I'm about to show you guys is going to be able to handle any amount of tiles along the row, and just depending on if the hole is in the same row or column. So if I click the 14, both the 14 and the 15 will slide over. 15 will be here, 14 will be here, and the hole will be here. So we'll be able to move multiple tiles in every which way direction, so long as the hole is aligned on the same row or column. So to get started, we want to have a just a simple reference to a button object, so we can kind of manipulate that button and move it around, because we're going to be using this as a temporary storage, because we are going to be moving the actual buttons around in our array as well. Because if we don't do that, then some weird things are going to happen when we start actually accessing some of these indexes in our grid button or our button grid array. So for the basic logic, if you know what, I'm just going to call this X and y, because that's a little bit easier for typing. So if x is less than whole x, so this is saying if the button that I selected is to the left of whole x, then I want to increment the position of the button by 51 to the right, and only on the x. So to start, we're going to have an interesting for loop because we only need to deal with whole x, and we want to move the whole around. So that actually makes it fairly nice to just use this kind of simple for loop, and we can modify the whole's location while still moving our buttons around properly. So while, oh, I'm sorry, that should be while the whole's position is greater than the button's x that we selected, we want to increase the whole once we move our button, or I'm sorry, subtract. I've cut them backwards. So we get a reference to the button that is next to the hole, and you know what, I should probably explain this a little bit more clearly first. Okay, just get through that. So again, because we want to handle sliding multiple buttons at once, we're going to start at the hole. This loop is going to start where the hole is, and then it's going to look at if the X of the button that we selected is to the left. Let's say we select 13, it'll start at the hole, and it'll just say, okay, move this button into the hole, and then set the hole to this position. And then again, we haven't met the X that we selected, so get this button, move it into this spot, and move the hole here. And then again, we still haven't gotten the hole here yet, so get this button, move it here, and then set the hole here, and we're done, because the hole now equals the X and Y that we selected. So that's kind of the cascade motion we're going for. So button equals button grid hole Y. Again, Y is the row that we're on, and hole X is the column. So hole X minus 1. And that's the part that I was talking about where we want the button next to the hole until we reach the X and Y of the button we selected. So now we want to add the movement action to our button, add action, move by, and this is going to be by 51 because we want the button to move to the right, and because this is a horizontal transition, we don't need to modify the Y value. We're just going to use a simple half-second interpolation to kind of give it a nice slide effect. POW 5 out tends to look the nicest to me. Oh, I think that's a capital O. Yeah. Alright. And now that we've moved that button, we need to do that swap that I was saying. So while visually the button's X and Y has changed, it hasn't changed in the array that we're working with. And because we heavily rely on searching through where the buttons are by their index, we do need to modify where the buttons are in our array as well, which is where this temporary slide button reference comes in handy. So button grid at the current hole Y and hole X equals button, and then button grid hole Y hole X minus 1 equals null. Okay, so that's where the swap comes in. So we're setting the button to where the hole was, and setting the spot where the button we just moved into the hole was to null. So that's where the new hole is. And the way we make the hole kind of move is this part of the for loop. That's why we do the minus minus. So it's kind of doing a lot of stuff in this for loop at once. But this should give us the basic action that we're looking for. So now we have our first case. We will be having 4 cases to handle up and down and left and right sliding motions. But let's just try this one getting tiles to move from left to right at the moment and see if it works. So we'll play real quick, and 15 we want to move to here, so it'll go, and there we go. And again, like I was saying, we have a cascading motion, so it's going to start at the hole and kind of move these ones one by one, and we get that nice effect as soon as we click 13, it'll be instantaneous on both of the buttons, which is really, really nice the way that turns out. So there we go. And because we don't really have any actions handling a case where the hole is to the left of the button yet, we just have to go back into our code and add that in real quick. So we have a nice single button or multi-button transition going on just with a single for loop here. So now we want else, and the reason I'm putting else is because it will neither be both the case that the hole is less than or greater than on the x and y. It can only ever be possible that it's one or the other, mostly because of this check. So we can pretty much just simply take this for loop and kind of reverse it. So that'll be plus, this will be less than, and that's so if the hole is to the left of the button we selected, then get the 1 in front of it, and then we're going to be subtracting on the x instead of adding, so moving to the left rather than the right, and then this should just be +1 to match this statement here. So now we should be able to move in both the left and right sliding transitions. Okay, play. So we can now move in both directions, and that looks, if you ask me, that looks great for this kind of sliding number puzzle game. Okay, and again, we can seriously just copy and paste this all over again and set this to be all the y. We can just go through here. Sorry about this. This will just take a second. This should be y. And then this should be -1 instead of this one. And because we're dealing with the y where the y is down as negative, we have to kind of flip these move by values. And you know what? That's actually still for the x. So this should be 0, and this should be 51. This should be -51. That should be 0. Okay. Replace this with -1. Replace this with +1. Y. Y. Okay, that looks good. Get rid of that. There's really not a lot to change, which is pretty nice. So now that we did that for the Y, and make sure you got all those changed properly. Make sure you made sure to do the action change so it's modifying the Y instead of the X, and also make sure you're getting the right index of the button you want. Now that we have move buttons down, we with all 4 of these cases handled, we are able to move on, and you know what, we can actually just add return statements here so it doesn't attempt to do those other oh, do we return is unnecessary in the last statement? I guess that's true. So yeah, if the x gets hit, then I guess it'll return regardless. So now we can continue for, that shouldn't be an error, but did I remove something? Unreachable statement. Oh, okay, whoops. Sorry about that. Okay, so I forgot. Because this is just a generic else statement, it'll not return. Okay, forget the returns. It will only ever do this check anyway, so we can just forget about that. And so we load it up, and now we should be able to move all of our tiles however which way we want to, and it'll look nice. It's got a nice slide transition, and now we can start scrambling our numbers and getting our game going. So we now have some functionality to our game, and let's see. So we want to let's get things jumbled before we get out of here. I think once we get our numbers jumbled and our whole position jumbled, I think that's going to be the end of this video. There was a little bit of logic going on here, so I think that might be enough content to get you guys going. But first things first, we're going to have a basic array of integers. This is just how I'm going to do it, called nums, and that is the bad logic GDX utils array type, equals new array integer. Okay, and then for int I equals 1, I is less than board size times board size, so that would be 16, I plus plus, and nums dot add I. So what this loop does is it's going to go through and add 1 through 15 to this number array, or this integer array, and then in here we can just, every time we get to a new button that we want to create, we can just set the ID to the first of the numbers and take that number out of the number array until we're done building our grid of buttons. So what we're going to want to do, instead of this tricky formula we got going on here, we just do nums dot remove, or wait, it should be remove index 0. Okay. Yeah, and so let's see what that gives us real quick. I wonder if that still maintains the the grid order. Okay, so yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so now that it's just pulling in this from the array, instead of calculating it based off of the row and column that it's currently at, we can just simply call nums.shuffle. And this is a really nice feature to just have on these arrays that LibGDX provides. You can just shuffle an entire array of numbers really quick, and that'll give us our instantaneous shuffling capability for our grid. And look at that. That's awesome. We're already done with that now, and we can move on. But now we get a different kind of, if you notice, I think the ID might be a factor of, yeah, so right here. We might have to change that back to the other ID index number, so that still looks nice when they fade in. We can just take that, and we're going to move this to, instead of ID, it's going to be this equation we came up with last time, and then this again is just going to be set back to nums.remove index 0. So we're getting the first index every time, and because we're pretty much guaranteeing we're going to have enough numbers, we shouldn't get any index out of bounds problems. So nums.shuffle again, and hopefully we'll get that same cascading entry of the grid like we had before, since we're using the right delay now. So play, yep, okay, there we go. That's what I was hoping for. So again, we can still move our buttons however we want, and things are looking good. So time to shuffle the whole, and that's just going to be mathutils.random. That's going to go to board size. And I'm not sure if that should just be all we have to do. I forget if mathutils in the LibGDX library is inclusive or exclusive, but I'm sure we'll find out in just a second if we run it enough times. Okay. There's the new hole. Yep, it's looks like it's inclusive, which is not what we want. So we want to get -1, -1. Which is strange. I'd figure 0 would still be part of that. So there we go. There's that. Okay. Index can't be greater than size. 0 is greater than or equal to 0. Alright, well, that was a little unexpected. Remove index. Play screen, index, out of bounds. I++. Nonstop Shuffle. X remove 0. Alright, sorry about this one. This was kind of a last minute addition for shuffling the whole in X. I didn't really plan that one ahead of time. Init grid, show, array index out of bounds. Alright, well, you know what? I'm just going to stick this to 3 and 3 for now. And I'll kind of touch back on the next video just so we can get this one kind of squared away. So with that, I hope you guys enjoyed getting these sliding buttons move around. Hopefully that wasn't too difficult to understand the logic going into that with the for loops. If you want, here's just again a quick display of what's going on here. And of course, if you guys have any questions, just put them down in the comments, and I'll be sure to answer them when I get a chance. So with that, thank you for watching, and hope to see you guys in the next video where we finish it off.